Quantitative Data Analysis Techniques 4.5. Researchers use quantitative data analysis in order to test hypotheses and try and discover new relationships. According to Adams et al. 2010, quantitative data research is a formal, objective and systematic process in which numerical data is used to obtain information. This type of research is mostly deductive. This means that the researcher has a hypothesis and then begins their observation to test the hypothesis. It's mainly used for the purpose of finding patterns of behaviour or dominant themes. This is more useful than qualitative research, as the latter can be very vague depending on the methods used to collect it, whereas qualitative data analysis is subjective because the data collection is based on or influenced by personal feelings, tastes, or opinions of the researcher. Quantitative research is objective because it's based on figures and numbers. It also involves larger sample sizes, so it's easy to find patterns and trends with data. In order for the researcher to draw conclusions and decide whether or not they're able to accept or reject the hypothesis, the data needs to be organised into a logical, systematic way. Organising data is very important because you can find and resolve any inconsistencies in data, and once organised, the data itself can provide useful insights into finding patterns and relationships more easily. There are many different ways of organising data. It depends on the type of data and the size. Here are the different ways of organising data. You can use the range rank order distribution, simple frequency distribution, and grouped frequency distribution. The range, this is the highest value to lowest value, and according to Adams et al. 2010, range is the distance in numerical value from the highest to lowest value collected. This is calculated by taking the lowest value away from the highest. One of the limitations with using the range is that if there are any anomalies, a single data value can greatly affect the value of the range, and it makes it less effective for the researcher. The purpose of the range is to see the difference between the highest and lowest values. An example is on screen at the moment. So to work out range of standing vertical jump, you need to find the highest value in the column, which is 56, and the lowest value, which is 15. And you do 56 minus 15 to get the range of 41. Rank order distribution. This is the smallest value to the highest value in rank order distribution. Adams et al. 2010 states, rank order distribution means that placing your data in order listed from the lowest to the highest in a single column ensures it includes all the scores. This type of data of preparation works best if there are 20 or less numbers. The positives for using this is that you can see which result got the highest score and which one got the lowest, and can be important to see who did the best in comparing them. This type of preparation depends on the type of data you're using you're analysing, which is negative. The first image is a random order, and the second one is when both are being put into rank order from the lowest value to the highest. Simple frequency distribution. According to Adams et al., simple frequency distribution is used when numbers of participants greater than 20. You use simple frequency distribution when the table has two columns, one for the raw data scores and one for frequency scores. The frequency column is the number of times that a particular score is achieved. Frequency tables are widely utilised as a glance reference into the distribution data. They're easy to interpret, and they can display large data in sets in a compact number. Frequency tables can help to identify obvious trends within the dataset and can be used to compare data between datasets of the same type. Frequency tables aren't appropriate for every application, however, there can be hazo or extreme values, for example, a number of a set amount or under, and do not need them to analyze the slant of data. According to Adams et al. 2010, in quantitative research, you often work with ranges greater than 21 and with more than 20 participants. This is when you would use group frequency distribution. The advantage of group frequency distribution is that it is small enough for you to get a pretty good idea at a glance how the scores are distributed. The disadvantage is that you are lumping scores together, thus losing some of the information in the original scores and you don't know the exact value of the score you got. To do this, you need to find the largest and smallest values, complete the range maximum to minimum, then you select the number of classes and categories desired. This is usually between 5 and 20. Find the class width by dividing the range by the number of classes and rounding up. There are two things to be careful of here. You must round up, and normally 3.2 would be 3, but in rounding up it becomes 4. If the range divided by the number of cases gives an integer value, then you can either add 1 to the number of classes or add 1 to the class width. Presenting data. There's lots of different ways of presenting data, and those will be followed through on the following slides. Scatter graphs are a good way of displaying data, as two sets of data can show a correlation or connection. The graph shows a positive correlation between the scores of flying sprint compared to static sprint scores. When the flying sprint scores are higher, the static sprint scores go up. However, it's important to remember that the correlation does not imply causation. If data plotted on the scatter graph shows correlation, we cannot assume that the increase of one set of data causes an increase or decrease in another set. It might be coincidence, or it may be cause some other relationship of the two. Graphs can either have a positive correlation, negative correlation, or no correlation. A positive correlation means that as one value increases, the other one does too. That's a positive correlation. Negative correlation means as one increases, the other decreases. No correlation means that there is no correlation between two variables. So if one goes up, it doesn't necessarily mean that one goes down or up. A line of best fit is a sensible straight line that goes into as central as possible through the coordinates plotted. It also follow the same steepness as the crosses, so you can use it to estimate the scores of the graph. A line graph, also known as a line chart, is a type of chart used to visualize the value of something over time. The line graph consists of horizontal x-axis and vertical y-axis. Most line graphs only deal with the positive number of values, so these axes typically intersect near the bottom of the y-axis and left end of the x-axis. The point at which these axes intersect is always 0, 0. Each axis is labelled in the data type. Data points plotted are connected by a line of dot-to-dot fashion. The x-axis is also called the independent axis because its values do not depend on anything. The y-axis has the dependent variable on because it's dependent on the x-axis. More than one line may be plotted on the same axes as a form of comparison. For example, on the line graph it is comparing speed of static sprint compared to flying sprint with a separate line for each. In this case, each line will be a different colour and identified in the legend. Also, you can use standard deviation bars to know how far apart the deviation is from the mean and median. Table, there are lots of different data needs to be sorted. One of them is emitted in the form of a frequency table. This is important to get the size of the groups when sorting data into a frequency table. Tables are the simplest way to represent data. A table complies to all data in columns and rows, so it can be easily interpreted. Bar chart. Bar chart is a bar graph is a chart of that presents categorical data with regular bars with heights or length proportional to the values that they represent. The bars can be plotted vertically or horizontally. A bar chart, like a frequency graph, shows the frequency of the event occurring. The height of the bar is the frequency the bar chart may be needed to compare data. A comparison bar chart shows this information. The key that shows which bar represents the data is necessary to be able to read a bar chart properly. A bar chart shows comparison among discrete categories. The axis of the chart shows specific categories being compared, and the other axes represented measure value. Some bar graphs present bars clustered into groups more than one, showing that values in more than one vector. Box plot and whisker. Box plot and whisker diagram shows a visual representation of the median and the quartiles of set data to draw a box plot. The following information is needed: the minimum value, lower quartile, median, upper quartile, maximum value. A box plot can be created from a list of numbers by finding the median and lower and upper quartiles. To find the lower quartile, if there was 11 numbers, so 11 plus 1 divided by 4 equals the third number. The lower quartile will be the third number, and the upper quartile is the ninth number. Histograms. A histogram looks like a bar chart, except the area of the bar and it not its height shows the frequency of the data. Histograms are typically used when the graph is in group data or groups of unequal width. A histogram is graphically displayed of data using bars of different heights in a histogram. Each bar groups in the range of numbers till the bars show more data falls in the range. A histogram displays the shape and spread of the continuous sample data. A histogram is the most commonly used graph to show frequency distribution. The area of the bar represents the frequency, so the height of the bar divided by the frequency by the class width. Once the frequency distance known as histogram can be drawn. Normal distribution curve. A normal distribution curve has a bell shape and is symmetrically around the center, so the right side of the center is a mirror image of the left side. Most of the continuous data values in the normal distribution tend to cluster around the mean, and the further the value is from the mean, the less likely it is to occur. You can skewed data distribution. Skewedness refers to the distortion or asymmetry in the symmetrical bell curve or normal distribution in set data. If the curve is shifted to the left or to the right, it is said to be skewed. Skewness can be quantified as a representation of the extent to which combined the distribution varies from the normal distribution. A normal distribution has a skew of 0. A negative skew is when most of the data to the right side, making it asymmetrical. A positive one is when most of the data is to the left side, making it asymmetric. This determines what tests do dependent on if the data is skewed or not. Outliers. When you have a piece of data that doesn't fit into the rest, it's higher or lower, it is known as an outlier. Outliers affect data because when you put them in a diagram, they make it hard to see, and example statistics bring outliers may give the rest. There are ways of correcting this.